Welcome to This Explainer. Today, we are stepping right into the mind of a Cambridge psychologist. Well, effectively, an examiner's mind, to master the exact strategy you need to jump from a B to an A star in your mathematics exams. Whether you are tackling IGCSE 0580, Additional Mathematics 0606, O-Level 4024, or the higher-level 4037 and 4040 papers, the psychological game of the exam is exactly the same. Today, we're focusing on a notoriously tricky topic, composing and resolving velocities to determine resultant vectors. But listen, we aren't just going to sit here and crunch numbers like a textbook. We are going to decode exactly what the examiners are actually looking for when they mark your paper. To really understand this challenge, I want to introduce you to two very typical students we see all the time. First, there's Alex. Now, Alex overloads every single answer with raw mathematics facts, formulas everywhere, but zero actual analysis or structure. Then we have Sam. Sam rushes through everything, panics, and completely misses the specific command word requirements in the question. Today, we're going to look at their flawed answers, look at all those red pen marks, and transform them into absolute perfection.
Okay, let's dive into this quote directly from the examiners, which establishes the foundational academic benchmark for composing and resolving velocities. When you read this, it should fundamentally change how you approach your past papers. Cambridge examiners are telling us directly that they don't just want to see that you've memorized a formula and can plug numbers into a calculator. They want to see depth. They want to see that you understand the physical and mathematical mechanics of adding two or more vectors together and that you can articulate that process clearly. Think about Alex for a second. Alex would look at a velocity question and just write down a massive calculation block. That is superficial breadth. Alex knows the math, sure, but there's no depth, no story, no logical flow. Sam, on the other hand, might just write down a final number and skip the working entirely because they rushed. Both of them fail the assessment framework right here. The examiner wants to see your analytical depth on full display.
Here's our roadmap to understanding this method mark strategy and bridging that gap to a top-tier grade today. We're going to cover Section 1, the A-star difference, Section 2, the core principles, Section 3, the precise procedural sequence you need, Section 4, critical analysis, Section 5, examiner warnings directly from the source, and finally, Section 6, your winning strategy. Let's get right into it. Let's start by looking at what actually separates an average math paper from an outstanding one. In Section 1, the A-star difference, focusing entirely on process over final answers. This is where we shift our mindset from just doing math to actually engineering a grade.
So the absolutely crucial point here is that examiners are evaluating your procedural framework, not just hunting for a correct final number at the bottom of the page. This is what we call the method mark strategy. When you are composing velocities, say taking an aircraft's velocity vector and combining it with a crosswind vector, that final resultant vector is honestly only worth a fraction of the total marks. The bulk of your score comes from proving to the examiner exactly how you got there. If you make a tiny, silly calculator error right at the very end, but your written process is flawless, the method mark strategy ensures you still secure almost all the points. Sam lost 6 marks on a recent 0606 paper simply because they just wrote the final resultant bearing. No vector triangle drawn, no horizontal and vertical components clearly listed. You cannot let that happen to you. It's all about the process.
Let's transition to the foundational concepts that you must embed into every single velocity problem you tackle. This is Section 2, Core Principles, Building the Foundation. Now, this is where we begin our strategy reveal. But before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. All right, let's break down the command words and build that foundation.
Think of yourself as a lawyer stepping into a courtroom. But instead of arguing the law, you're arguing with geometry, trigonometry, and vector mechanics. Your mathematics must be an evidence-based argument, systematically laid out for the examiner to follow. Every time you resolve a vector into its horizontal and vertical components, you are performing systematic analysis. You are providing mathematical evidence for your final conclusion. This is where top students use a variation of the Peel framework: point, evidence, explanation, link, adapted for mathematics. Your point is stating your intention, like resolving horizontally. Your evidence is your specific trigonometric equation, like v cosine theta. Your explanation is your clear algebraic manipulation, and your link is stating your final vector in the exact format the command word asks for. Alex completely ignores this structure and just throws a jumble of numbers onto the page, hoping the examiner can find the logic. You have to be better than that. You have to be structured. This brings up a really vital question, doesn't it? How exactly do we display this logical reasoning on the exam paper to maximize our score? It's all well and good to sit here and say we need logical reasoning and evidence-based structures, but what does that actually look like when you're staring down a blank page, the clock is ticking, and you're sweating over a complex 4024 paper? Well, it's time for a transformation. We're going to take those red pen marks on Alex and Sam's papers and turn them into green check marks by rewriting their answers live.
Let's look at the exact procedural sequence examiners expect to see when you compose and resolve velocities. This is Section 3, Procedural Sequence, the standardized blueprint.
Now, what's really interesting about this slide is how it turns a complex, multi-vector problem into a rigid, foolproof checklist. This is our mathematics success blueprint. The principal examiner reports emphasize that systematic processing follows this exact sequence. Step 1. You identify the key elements, extracting the magnitudes and directions of your initial velocities from that dense paragraph of text. Step 2. You apply the relevant principles. Are you using the sine and cosine rules for a non-right-angled vector triangle, or resolving into I and j components? Step 3. You execute with crystal clear working. Step 4. You verify. Does the answer actually make physical sense? Step 5. You present your resultant vector in the required format. Let's rewrite Alex's answer using this. Alex just wrote v equals 15. No! Following the blueprint, Alex now writes resultant velocity v equals 15 meters per second on a bearing of 0.45 degrees. See the difference? That is how you secured every single mark.
When facing the actual exam question, applying this specific step-by-step extraction and execution sequence ensures you don't miss those vital method marks. Notice the heavy emphasis here on clear notation and correct terminology. If the question uses unit vectors I and j, your working should confidently utilize that exact same framework. If you just throw random numbers onto the page without labeling your horizontal and vertical resolutions, the examiner literally cannot award you those process marks. They aren't mind readers. You have to show them the analytical framework you selected. Okay, take a breath. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Let's keep moving. All right, let's jump into Section 4, Critical Analysis, Elevating Your Answers. This is where we step into our interactive workshop. I want you fully engaged here. Let's see how this builds into the higher-order assessment objectives required for those absolute top marks. I'm putting a mental 60-second timer on the clock for Challenge 1, Data Scan. Look closely at this table. This framework demands you escalate your thinking from merely descriptive to fully evaluative. Do you see the trend? Most students, frankly, stay permanently stuck in the descriptive and analytical tiers. They can extract the data, they can do the basic math, but the A-star candidates, they reach the evaluative level. They can look at a complex mathematical scenario, like a boat trying to cross a river with a shockingly strong 10-meter-per-second current, and evaluate if a certain path is even mathematically possible given the engine's constraints. They justify their decisions with the hard data they've calculated. If you are only ever describing the math, you are leaving the best marks on the table. You need to question and evaluate. Okay, moving to Challenge 2, Find the Flaw. I want you to imagine a paragraph where Sam writes, Route A is faster than Route B because the wind is helping more. Can you spot the flaw? Where is the comparative connective? Where is the mathematical evidence? When comparing approaches or alternative vector routes, you must identify both similarities and differences, supporting each and every claim with concrete mathematical evidence. To get full marks, Sam needs to say, while both routes cover the same displacement, Route A results in a resultant velocity of 250 kilometers per hour compared to Route B's 210, proving Route A is more efficient. You have to use comparative connectives and show the exact difference in the resultant velocity vectors. That proves your point beyond a shadow of a doubt to the examiner. Now for perhaps the most valuable insight of this entire explainer, a direct, unfiltered look at the principal examiner reports and the massive traps you must avoid. Section 5, Examiner Warnings. The examiners explicitly warn against these top 3 formatting and contextual errors that cause otherwise brilliant students to just bleed easy marks.
For challenge 3, I want you to imagine speed writing a perfect final answer that avoids these. It is incredibly frustrating for an examiner to see you perfectly calculate a resultant vector using complex trigonometry, only to have to penalize you a mark because you forgot to state the direction as a 3-figure bearing as the command word explicitly requested, or because you failed to check your presentation and didn't underline your vector notation. Proper format and presentation are absolutely non-negotiable for the Cambridge examiner. Don't be like Sam, rushing at the end and losing a mark because you wrote 45 degrees instead of 0.45 degrees.
Look at this direct examiner alert. This is a massive, glowing red warning sign for you. Always link every single point and calculation back to the given scenario. If the problem you're solving is about a swimmer trying to cross a tidal river, your final statement should never just be v equals 5. It needs to be fully contextualized. What does that 5 meters per second actually mean for the swimmer's journey? Examiners absolutely despise generic floating math that exists in a void. They want applied mathematics. They want to know that you know what you just calculated. State, the resultant velocity of the swimmer relative to the riverbank is 5 meters per second. That is how you lock in the final mark.
Here, we can clearly contrast the superficial average approach with the analytical, evidence-based A-star strategy. The average answer, the classic Alex answer, is just a giant block of numbers ignoring the context. But the A-star answer, it tells a complete mathematical story. It shows the initial velocity components laid out beautifully, it shows the clear algebraic addition of the vectors, it shows the calculation of the resultant magnitude using Pythagoras, the trigonometric deduction of the angle using inverse tangent, and finally, a concluding sentence that explicitly answers the real-world scenario posed in the prompt. That is the transformation we are looking for. Let's bring all of these examiner insights, all these corrections, together into a comprehensive, holistic system for your final revision. This is Section 6, Winning Strategy, bringing it all together. These are the 3 rules that guarantee top marks. First, command word decoding, questioning assumptions based on exactly what is asked. Second, Peel framework application, justifying all decisions with structured mathematical evidence. And third, utilizing a time management matrix that incorporates the visual story method to encode complex concepts rapidly. When you are studying how to compose velocities, don't just stare blankly at a list of formulas. Visualize the physical story. Picture the airplane fighting the aggressive crosswind. Sketch the ship navigating the swirling ocean currents. Draw those vector triangles out big, bold, and clearly labeled. Encode that standardized procedural sequence into your muscle memory so that on exam day your hand knows exactly how to structure the argument. Now listen closely. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here is your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. I want to leave you with this final provocative thought to really challenge your entire approach the very next time you sit down with the past paper. Are you just doing math, blindly throwing numbers at a page like Alex? Or are you building an absolute, undeniable, evidence-based argument that forces the examiner to give you an A-star? Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here. Keep pushing, keep practicing, and I will see you in the next explainer.